Okay, so guys, today we are going to discuss Cisco SD-WAN, and this is just a demo class. Okay, it's just a demo class, and I will try to cover basically all the things on this demo, the basic stuff, so you will get the idea what is basically Cisco SD-WAN. And the guys live batch for this particular technology, we are starting from 10th of September. It's a weekend batch, so your classes will happen Saturday and Sunday starting from 6 p.m. to 8 p.m. IST. The fees for this particular training is 10,000 INR. So if somebody interested for this training, they can basically contact us on these number. This number is owned by me, the first one. So if you have any doubts with regards to the training, I'm gonna help you with that. Okay, cool. So what I will do, guys, first I will go through with the course content. This is how I will basically go. So we will discuss the course content which I am basically planning into this particular training, Cisco Viptela SD-WAN training. And after this course content, I'm going to discuss what are the lab topologies I'm going to use and how we can basically build the lab, so where we can do almost all type of practicals with regards to your Cisco SD-WAN. And after that, I will discuss 2-3 topics as well on your SD-WAN classes. Okay, so these are the things which I am going to cover now. Let me just go through with the course content, guys. This is again, if you will see, my organization name is Skilled Inspirational Academy. We have a website which is with the name of cnets.com. And apart from this is our website cnets.com. So if you will search on Google, you will get our details. We have a YouTube channel as well. So one YouTube channel name is cnets, and another YouTube channel name is Skilled Inspirational Academy. We do have a video portal. So this is our video portal where you will get some pre-recorded videos as well. Now, so basically in this training, what you need basically, or if you will say, I have mentioned here, this particular training, I will start from the basic and I will take you till the advanced level. Once we will basically complete this particular training, we will discuss all the basic fundamental basic concept of SD-WAN. Then we will go through with the advanced concept as well. And once we will complete all of them, I will also run through the SD-WAN troubleshooting. So I will take around 5 to 6 dedicated classes on your SD-WAN troubleshooting. Okay, now in this training, basically who can join this training? So the person basically who is having experience on either on routing switching, either on security background, they can basically join this training. Prerequisite for this training, you should have a CCNA level knowledge, guys. If you have a CCNA level knowledge, you are good to go for this particular training. Now, so in your first class, what I am gonna discuss introduction of your wide area network, because if you will see SD-WAN, right? If I'll tell you the full form of SD-WAN, SD-WAN stand for software defined wide area networking, which means here this particular technology manages your WAN, or which is your wide area network, with the help of some programmings, with the help of some software defined approach basically. So but we have to first understand the wide area networking, right? What is WAN? What are the different technology we are having in your WAN, right? What is lease line? What is MPLS, right? All these things I'm gonna cover. What is frame relay, right? And once we will go through with that, I will also tell you the history of WAN, how basically WAN evaluated over the years. Once I will done with that, I will go through with the what are the limitation basically we are having in your wide area networking, right? Because see, this SD-WAN came in a market due to these limitation basically, because in your WAN there are lots of limitations are there, and all these kind of limitations, or we can say problems, is solved by the software defined wide area networking, or it is solved by the SD-WAN. So we have to see what are the issues we are having in your traditional WAN environment, right? Once I will done with that, I will go through with the how data center and your service provider implementation is happening, right? How they will connect all these things with the help of WAN. Once I will done with that, I will go through with the introduction to SDN. SDN stand for software defined networking, because your SD-WAN, it is one of the SDN technology only, or I can say SD-WAN is one of the SDN solution. So we will see how Cisco, what is the like Cisco SDN solution for your data center, what is the Cisco SDN solution for WAN, or if you will see SDN solution for WAN is your SD-WAN here. So this is the topic I am gonna cover in detail, guys. And after that, I will discuss what is the SDN solution for LAN network, which means we have a SD access. What is this SD access solution? I will just give you the overview here, but in detail, we are basically discussing your SD-WAN technologies. Once we will done with that, so these are the some theoretical information only, guys. Once I will done with that, I will go through with the introduction of your software defined wide area networking, where we will see how we used to manage your WAN before SD-WAN, and after that we will go through with the overview of your SD-WAN. Then we will go through with the advantages of SD-WAN, and after that I will go through with the concept of your underlay technology and your overlay technology. Okay, so we will go through with these technology, what is underlay, what is overlay. Once I will done with that, I'll basically go through with the architecture of your SD-WAN, where we'll see what is control plane, what is data plane, what is management plane we are having in your routers. Then what are the SD-WAN components we are having? Now, guys, with the help of your SD-WAN components, how we can control these control plane, data plane, management plane of and router. So we in your SDN we have a controllers like vManage, vWAN, vSmart. I will go through with these details. What is vManager? What is vWAN? What is vSmart? Once I will done with that, I will also discuss the transport. What is your MPLS transport? What is your internet transport? What is your cellular transport? Or I can say what is your 4G and LTE transport? Then we will I'll move forward after that, and I'll go through with the SD-WAN controllers and WAN edge deployments. These are the WAN edge means they are the WAN edge routers. So I will go through with the deployment option. What are the deployment option we are having? Are we able to deploy them over the cloud environment? How we can, what are the things we have to basically take care? What are the design problems we will face in the cloud environment, right? And what are the design problems we will face if we are planning to deploy on-prem environment, right? So all these things I'm gonna cover basically in detail. And after that, I will also discuss, there's a one very, very important topic in your SD-WAN, which is plug and play and jet TP. How this particular process happens, we will see in detail, guys. And after that, I will discuss multiple use cases basically. If we have a your WAN controllers behind the firewall, then how they will communicate? What are the things we have to take care, right? Is your WAN controllers need a public IP or private IP? How we can make sure the reachability, right? All these things I'm gonna cover, guys, here in your deployment section. Then we will also see here if we will go with the Cisco hosted deployment, which means if we will take the SaaS services from Cisco, means Cisco will responsible managing everything. How we can basically achieve these things. So we are going to discuss everything in detail in your deployment section. Once we will done with that, I will basically tell you your management plane, which is your vManage in detail, your orchestration plane, which is your vWAN in detail, your control plane, which is your vSmart in detail, then your data plane, which is V as in C's routers, or we can say your WAN is routers. So your WAN is routers or your data plane, they are the similar thing, guys. We will discuss that. And after that, we will also see What is the function of your vManage? What is the functionality of your v smart? What is the functionality of vWAN? And what is the functionality of your Viptela is routers and your Cisco is routers, basically. So we will discuss all these things in detail. Once I will done with that, I will basically move towards the most important topic of your SD-WAN, which is control plane. In this control plane, or I can say, I will discuss here control connections in your SD-WAN, because I have seen most of the peoples, they are not able to troubleshoot the control plane related issues, because they don't know the exact procedure of these control connections, how they will form these control connections, what are the commands you can use for the troubleshooting purpose, right? So we will discuss these things in detail. Like here we will see function of your TLS and DTLS tunnels, control connections, overlay management protocol, OMP routes, VFD. What is VFD? How VFD is basically helping us here. Then we will see controller and WAN is hosting options and platforms. So we will see all these details. Once I will done with that, I'll move towards your data plane of your SD-WAN, where we will see what is TLOC. Just give me 1 second, guys. Then we will see what is TLOC. What is the function of TLOC color and carrier? What is the ECMP mechanism? So we will see all these details. And after it, I will discuss types of VPNs in your SD-WAN. What is the management VPN? What is your transport VPN, which is VPN 0? And what are your service VPNs? So we will see in detail and how we can create all these things. Once I will done with that, I'll move towards the next topic, which is what is the need of network security and certificates in your SD-WAN. So I can say here we will discuss the cryptography. Here I am gonna cover your cryptography, where we will see network security in SD-WAN. Then what is trust? What is the CIA, confidentiality, integrity, and authenticity? What is encryption? What is hashing? What is authentication? What is your public infrastructure, PKI? What is your certificate authority and digital certificates? We will see all these things in detail, guys. And after that, in this we will see almost all the cryptography related stuff, like what is root certificate, what is intermediate root certificate, what is identity certificate, what is the certificate signing request, right? How your identity certificate is validated by the root certificate, what is the certificate chain, what is control identity, right? And after that, we will see what type of PKI infrastructure is supported by your SD-WAN. So we will see all these 4 types of PK infrastructure in your SD-WAN solution. Once we will done with that, I'll move towards your some basic terminology in your SD-WAN, which is what is system IP, what is organization name, what is site ID, what is the chassis number and serial number and token number in your SD-WAN. So we will discuss these very basic things here. And after that, I will just move towards the configuration object of your SD-WAN, which is also known as templates. Here we will discuss what is feature templates and what is device template, how we can create these templates so we can reuse on different locations. So we will see in detail how we can create. And after that, I'll just move towards your policies. This is the heart of your SD-WAN, I can say, because what type of traffic engineering you want to achieve, it is only possible with the help of policies here. So we will see the policy basics, then we will see SD-WAN policy framework, what is centralized control policies and what is the data policies, what is localized control policies and what are the localized data policies. So we will discuss in detail all these things. And after that, I'll just move towards your detailing in your centralized control policy. We will see what is centralized control policy, right? What is inbound and outbound control policies. Then we will do multiple labs. How we can achieve the hub and spoke kind of topology, how we can basically allow hub to spoke routing, right? All these kind of details we are going to discuss. So we will do multiple labs here in your security policies to achieve all these tasks, like what is service chaining, what is route leaking, right? How we can create a per VPN topology, what is dynamic on demand tunnels, right? How we can achieve the end-to-end path tracking, what is the VPN membership policies, right? So we will discuss in detail all these things. Once we will done with that, I'll just move towards your centralized data policies. In data policy, we will see the most important use case of SD-WAN is your direct internet access use case. How we can achieve, what is the access control list, what is net, how we can configure the network address translation and port address translation in your SD-WAN. How we can allow the trusted application only through the direct internet access. What is application pinning? What is forward error correction? What is packet duplication? So all these things we are going to discuss here. Then I'll just move towards the most important topic of your SDN, which is application aware routing, which means how we can write our security policies on the basis of application. Let's suppose you want to send your YouTube, Netflix traffic through the internet link, and you want to send your WhatsApp, Facebook traffic through the MPLS link, right? How we can achieve such kind of task? We can only able to achieve with the help of application aware routing, and we are going to discuss this thing. Once we will done with that, I'll move towards your localized policies. In localized policies, we will see what is localized policies, right? How we can manipulate the BGP routing, how to implement the access control list, right? So here we will see inbound ACLs and outbound ACLs, how we can write. Traffic pulsing, Cisco SD-WAN QS. So we will also see how we can apply the quality of service, right? Once we will done with that, and after that, I will basically introduce the C is onboarding, which is also known as your Cisco WAN is routers, where we will see what is VPN 0, VPN 1, VPN 512, what is VPN interface, right? How we can configure OSPF, EIGRP, all these details in your SIES routers. How we can implement your URL filtering, your IPS functionality, your F firewall into your SIES routers. Here I will use Cisco Cloud Seed Services router, CSR 1000V. So this is the router I'm gonna use for this particular lab here. What is zone based firewall, right? How we can do the upgrade process, what is the CLI template, what is software upgradations, we will gonna discuss in detail. Once we will done with that, I'll just move towards your quality of service. In quality of service, we will basically see what is QS and its needs, classification and marking, policing and safing, what is COS, what is TOS, and what is DSCP bits in your IP header. Type of queues, everything we are going to discuss here, guys, with regards to QS. And after it, I'll just move towards the configuration of high availability and clustering in your SD-WAN. How we can achieve the controller redundancy, or how we can achieve the high availability in controllers, like how we can put multiple vManagers, right? vManager 1, vManager 2, and vManager 3. How we can configure multiple vSmart, like vSmart 1, vSmart 2, vSmart 3. So all these details I'm gonna cover in your redundancy class or in your high availability class here. Then we will also see here how we can basically use our enterprise firewall, which means here we can also put your ASA, your Palo Alto, your checkpoint firewall, and we can basically send all the traffic into these firewalls, and we can basically configure different type of things, like we can configure SSL decryption, we can configure the IPS functionality, we can configure the URL filtering, we can configure the application based policies. If so, and on your labs, I'm gonna use here Palo Alto firewall for that, because Palo Alto have all these features. And once I'm done with that, I am basically going to cover your troubleshooting topics as well in your SD-WAN, where first we will basically, I will cover the advanced architecture of your management, vManager. Because so see, in vManager, it is having the Linux environment in a backend. On top of this Linux environment, they are running the Viptela operating system, right? Which means if it's a Linux environment, then we can do lots of troubleshooting of Linux environment and your Viptela operating system. So we have to understand how each and every process they will communicate with each other, right? What are the different types of daemons is running in a backend and how we can troubleshoot these daemons, right? So we will see that details. Then I will discuss how we can troubleshoot the vWAN and vSmart, how we can do the troubleshooting for your VS routers. Here we will also discuss the advanced architecture of your VS routers, advanced architecture of your CS routers and troubleshooting. Then we will discuss how we can do the control plane troubleshooting, how we can do the data plane troubleshooting, how we can do the IPsec connection troubleshooting, how we can do the BFD troubleshooting, how we can do the security policy troubleshooting. Then we will also see how we can run the packet capture in your routers using the monitor command. How we can basically see, because your all the controllers of your SD-WAN and your Viptela routers, they are running Linux environment, which means your Linux will support the TCP dump command, right? So how we can use the TCP dump command to capture the packet, and how we can basically upload this particular file into your laptop, and later on we can analyze with the help of Wireshark, right? And after that, in your SD-WAN, we have a vManager controller, which is also which will also provide you lots of troubleshooting utilities. You can run the trace route, you can run the ping, you can basically do the monitoring, health monitoring and all, right? So we will also discuss these troubleshooting utilities. Once we will done with that, now let me just tell you what are the devices I'm gonna use in my lab. So in my lab, I will use vManager, vSmart, vWAN, Viptela routers, and your Cisco router, your Palo Alto firewall. If needed, I can also add ASA, but right now I'm just only having Palo Alto here. Then I will use one Windows machine, one Linux machine, and one few routers for your WAN transport, which is your MPLS and internet routers. These are the devices I'm gonna use in my lab. Now, this is the lab topology I'm gonna use basically for your classes. So don't worry, I will tell you all these details now. If you will see here, if I'll go into my topology, this is the one of the topology which I'm gonna use. So guys, around your 70% practicals, we can able to perform into this particular lab. So this lab topology will cover around 70% of your lab. Once we will done with this step topologies and all, and after that I will introduce new topology, which is this one. Let me just show you that topology as well, which is known as SD-WAN advanced lab. So guys, when we will wants to do the practicals of some advanced feature, right? Like your redundancy, here you will see I have a 3V managed controllers, 3V smart, 3V one controllers, right? So your redundancy labs, I am gonna use this topology. Your high availability lab like your VRRP, your T-lock extension, all these labs, I am gonna use this particular topology. Then we will be also your service route related topology is this one. So I will use this particular topology, right? So these are the two lab topology which I'm gonna use. Let me close this one. So first I will use this one in your almost 70% classes. Okay, cool. Now, as I have mentioned, this particular classes I'm starting from 10th of September. It's a weekends batch, guys. So your classes will happen Saturday and Sunday, and timing is 6 p.m. to 8 p.m. and fees for that training is 10,000. Okay. Now like in this basically in SD-WAN demo, let me just go through with the some small topics. Basically, I will not go into too much details, but I will go through with the SD-WAN architecture, traditional routers, and your SD-WAN controllers. Okay, I will not go in detail, but I'll give you the overview of them. So if you will see, I have taken here 2 routers, let's suppose. These are the 2 routers I'm having. Now always remember guys, in this router, let's suppose I have here one management PC. Let's take an example. This is the one of the management PC I'm having. So if I want to do any kind of configuration in these routers, what I have to do? I have to connect with the console cable or either management port, right? So let's suppose this is the console port here. And same, we do have one more console port here as well on this. So let's say I have connected my PC with the console cable of these routers. Now, after basically logging into these router with the help of console cable or with the help of console port, I will do some type of configuration, right? I will do some type of configuration on these devices, right? So if I'll tell you the something here, so in these routers we'll see we have these interfaces, right? These are the interfaces, or we can say your NIC cards, or you can say these are your data cards. And your actual systems of servers, we will connect into these ports, right? And these are the ports who is responsible for your traffic, which is initiated by these servers and all who has a connectivity, maybe server 1, server 2, server 3, right? All these servers, they will send the traffic here, right? Now, so in your router, generally what we have, we have your interfaces or data cards. Apart from this is the one thing you will see in your router. And the second thing in your router you will see, it is having some CPU and it is having some memory, right? These things also you will see. And guys, inside this router, basically, we have a very important component which is known as route processor. That component is known as route processor, or I can say this route processor is also known as control plane. What your route processor is also known as your control plane. And your data ports, these ports, they are also known as your data plane. Now these console port, whatever management port we are having, this thing is known as your management plane. So if I'll tell you the basic thing regarding a router, what it is having, 3 planes majorly, right? It has the management plane, it has the control plane, or which is also known as route processor. And the third thing, what it is having, the data plane. This is your control plane, right? These are the 3 planes which we will be having in your routers. Okay. Now let's take an example, guys. What I want, let's suppose I have this type of setup. These are the 2 routers I'm having. So let's say this interface on this router has a connectivity with the one of the interface here. These routers, they have a connectivity with each other. Let's suppose this interface is gig 0 by 0, and on other side also this interface is gig 0 by 0. Apart from this interface, I do have these interfaces. So let's suppose I have these 3 interfaces where I have one PC here, and let's say I have these servers here. So this is your PC1, server 1, and server 2. Let's suppose here you are using network of 10.1.1.0/24. And on these interfaces, let's suppose this interface is your gig 0 by 1, this is your gig 0 by 2, and this is your gig 0 by 3. Let's so these are the 3 interfaces we are having. And these interfaces, let's suppose it is having 11.1.1.0/24 series, and this one having 12.1.1.0/24 series, and here we are having 13.1.1.0/24 series. These are the 3 networks we are having behind this particular router. Let's suppose this router is R1. This router is R2. Now in this router R2, what I do have these interfaces. And behind these interface, let's suppose I have one PC here. This is PC2. And I have these servers here as well. Maybe server 3 and server 4. Now, this PC having a range of IP which is, let's suppose, 20.1.1.0/24, and this one having range which is 21.0.0.0/24, and this one is 22.1.1.0/24. These are the three subnets I'm having, guys. Okay, cool. Now, let's suppose I got one requirement. One day, my manager came and he just asked, can you just allow the communication of these three subnets with another these three subnets? This is the requirement I have received from my manager. And he's just asking, can these people, they can able to communicate with each other? So I'll just say, yes, they can able to communicate. If they wants to, or if I wants to allow the communication between these networks. And what he said, so what I have decided, if I want to allow the communication between these networks, so I have decided what I will do, I will go with the one of the routing protocol is known as OSPF. What I am going to run OSPF protocol between router R1 and between with your router R2. So when I will run the OSPF protocol, these networks and these network, they will basically synchronize or advertise towards each other, right? They can able to communicate. But now guys, just understand here one thing. If I want to do configuration on this router R1 and R2, what I have to do? I have to take the console access. I will log in into R1, right? I will take the console access of R1 and I will log in into this R1, and what I will do? I will configure the IP address in the interfaces, right? And after that, what? I have to configure the OSPF, right? On this router. These are the thing I needs to do, right? On R1. Same thing I have to do with the R2. I have to configure the IP address on all these interfaces, and I have to configure the OSP protocol on this. So this kind of configuration I need to do, right? So guys, if I want to, let's suppose, either I can take the console access, right? Otherwise, if I don't have a console access, so either I can go with the SHS access, or either I can go with the telnet access, right? These are the generally medium which we use for configuration purpose of these things, these routers, right? So guys, I think guys my voice is coming properly. Can you just confirm, please? Is there any noise at my end? Just confirm on chat. Say yes, no. Because I got one message. Sambu, just check your internet connection. Everyone able to hear me properly. Thank you guys. Thanks for the confirmation. Okay, let's back to the topic, guys, now. Cool. So if we wants to now to do these tasks, we wants to configure, right? We want to do the configuration. And how we will do? We will first log in on R1, we will complete the configuration, then we will log in into R2, we will complete the configuration, right? So guys, whenever we will take the access of this device, these are the CLI ways, right? If you know, we can also able to take the HTTP and HTTPS access as well on these routers. So guys, whatever media we will use, CLI or graphical user interface for the configuration of these devices, all these tasks is basically take care by the one of the plane which is known as management plane. So your management plane is generally used for whenever we will log in into this device, your management plane come in a picture. Now, second thing, Now we have configured the IP address. We have run the OSPF. When we run this OSPF protocol, what will happen, guys? Your R1 and R2, they will advertise the subnets, right? So guys, this R2, he will advertise these three networks towards R1, and your R1, he will advertise these networks towards R2, right? These things will happen. So R1 and R2, they will advertise the networks, or I can say prefix here. And when this router, he will receive these prefix, what will happen in your OSP, if you remember, it will maintain the LSDB or your LSC database, right? Your OSP, it always maintain the information of these prefix into something called LSA database, right? And what it will do, so it will create a LSDB table, and it will also create the neighbor table, right? Because if you will run the command so IPOSPF neighbor, right, which means it needs to maintain the neighbor table as well. Guys, this LSDB database is also known as your routing information base, RIP table, I can say. And all these tasks, who will carry? Who is responsible for doing all these tasks? All these tasks is basically done by the route processor, which is RP. And guys, route processor. So what it will do, when my R1, he will receive these three routes, what he will do? He will maintain the LSDB database, he will maintain the neighbor table, and what after that, in case of OSP, what it will run the shortest path first algorithm, right? It will run this SPF algorithm to basically calculate the best route or to calculate the best path. Apart from this, let's suppose we are using authentication, right? Then your authentication will also take care here. In your OSPF, whatever, we will exchange some kind of hello and heartbeat messages, right? So these messages, or we can say they will exchange some hello messages with each other. These hello messages will also take care by the route processor, which means, guys, all these things, they comes under your control plane. All these things, they comes under your control plane. All these tasks is basically done by the control plane of your router. Just remember. Now, third thing, when your R1 and R2, they will advertise the routes with each other. So these routes will install into the RIP table, which is managed by the route processor. And after that, this route processor, it will also maintain one more table is known as your ARP table, I can say. Your ARP table is also maintained by this particular route processor, or with the help of control plane, they will maintain. Now, after basically what they will do, after that, your RIB information is provided to your data plane as a FIP table, forwarding information base, and this is also known as your routing table. This table is also known as your routing table. So your forwarding information base, FIP table, or your CEF table in case of router. These tables is a part of your data plane, guys. Because when this PC here, let's suppose this PC here, he wants to send one ping request to server 3. So what he will do? He will create one packet, right? And he will forward this packet towards the router gig 0x1 interface. Now, on this gig 0x1 interface, when my router, he received the packet, so he will see the in this packet destination is 21.1.1. Let's suppose 100 IP address we are having here. So what it will do now, it will do the lookup into your FIP table, right? And to get the exit interface, it will do the lookup into CEF table. And after that, it will forward this data towards here. After doing the route lookup, Then this device he will receive, he will do the same thing, and he will forward the traffic towards here. So like that, they will do the traffic forwarding, right? So guys, your fib table and sep table is responsible for forwarding this packet, right? Which is initiated by this PC1 towards server 3. So these two things is a part of your data plane. So guys, I think you will understand now the functionality of management plane, functionality of control plane, and functionality of data plane. So guys, what the traffic which is initiated from these peoples is take care by the data plane of your router. In your data plane, it will do the data forwarding with the help of forwarding information base and your ceph table. Whatever OSP or routing protocol we are going to run here, right? All the calculation of best path, it is done by the route processor, and it's a control plane activity. This activity done by the control plane of your device. Whatever configuration we are going to do into these devices, this is done by the management plane. This is the pretty small environment, guys. This is a very small environment. Now let me just tell you one more thing here. If you will see, guys, this is the internal architecture of your control plane. I hope this image is visible to everyone. Just hit yes, no in the chat. Okay, so I got lots of yes. So if you will see here, this is the internal architecture of your routers. Basically, in this router, you will see we have a control plane, and here you will see this is the switch fabric I'm having here, and we have a data plane. So guys, your control plane and your data plane, they are connected through the fabric which is known as switch fabric. And whatever communication if they wants to do with each other, they will do through this particular switch or this particular fabric, guys. Okay, they will use this particular fabric, and this is the route processor is running into your each and every routers, guys. This is the internal architecture of your route processor. So your it will basically what it will do, it will take care of all the protocols. So let's suppose we are running EIGRP, OSP, BGP, right? All these protocols management calculation is done by the route processor only. It will do all kind of calculation and will provide the calculated value, which is also known as your routing table, or we can say your forwarding information base, fib table. Okay, all these things done by the route processor, guys. This is how it has a connectivity. Okay, now let me tell you one. Now this is the very small, we can say, diagram where we just have a two routers. Now let's see here. Let's take an example. Now I have here around these many routers. I have a R1, I have here R2, I have here R3, I have here R4, R5, R6, R7, R8, R9, and so on. Let's say I have till R9. This is my cloud environment here somewhere. You can say this is my MPLS cloud environment. Now, all these routers, they have a connectivity, let's say with this MPLS link through at any location. Okay, they have a connectivity like this. Now, and here I don't have these 9 routers. Let's suppose I have here 100 routers or maybe 1000 routers I'm having. And let's suppose all these routers, they are having this interface is gig 0 by 0. This is gig 0 by 1. Same setup, gig 0 by 0, gig 0 by 1, because we have done our designing very precisely, and all these routers, they have the symmetry, gig 0 by 0 and gig 0 by 1. Here also same thing, gig 0 by 0 and gig 0 by 1, gig 0 by 0 and 0 by 1, 0 by 0 here as well, then 0 by 1, Same thing here as well. And same thing I have here. Now, let's suppose now there is a one requirement came. My manager asked me, can we basically onboard all these devices in our network? Which means now I have to configure some routing protocols here. I have to configure the IP address here as well. And maybe I need to run the routing protocol as well on my LAN side. Same thing here I have to do here, right? Which means I have to do now similar functionalities, right? I have to do here similar functionalities into all these devices. And I am having around 1,000 devices. If you will see into on these devices, what is the like variables? Let's suppose I want to configure some routing, and I want to configure, let's say I want to configure same routing protocol. So that time, if you will see, IP address will change on all the devices, right? IP address will change. And apart from this, whatever routing protocol you will run, that protocol remains same. Your interface will remain same, right? Which means what we can do, if we can create some type of configuration script for one side, and we can use the same script into another side, we just wants to modify the IP details. That's it, right? So we can use that IP address as a variable, and we can do the same thing into all the devices, right? So guys, your SD-WAN work in this particular way only. What they used to do in your SD-WAN for configuring anything, what they just say, you can create a similar type of configuration. You can just create one form of configuration or one script of the configuration, and you can just fill the variable values, the values which are changing on each side, and you can do that configuration into all the devices at the same time. So that kind of flexibility you will get in your SD-WAN. So guys, what if you will log in into each devices every time, and you will do the configuration? How much time it will take? It takes lots of time, right? But let's say if you have something, some kind of mechanism where you can just log in into one device, and from this one device you can basically do the configuration. You have to just push the configuration, because they need a same type of configuration, only the IP address is changing, right? If you will get that kind of flexibility, you will able to manage the entire infrastructure easily, right? So guys, you're one of the controller, and guys, when we wants to log in into these devices and we want to do the configuration, this is done by the management plane. So what they have done, guys, in your SD-WAN, they have take out the management plane from all these devices in your SD-WAN. They have added some programming, and what they are having one controller is known as vManage controller. What this vManage controller will do, this it will manage the management plane of your router, which means if you want to do the configuration into all these devices, you can do from the single place. If you want to do any kind of troubleshooting, you can do from the single place. If you want to upgrade all these devices, you can do from the single place. You can create a templates or the same configuration script, and you can push them on all the devices at the same time. So that kind of flexibility you will get, and all this configuration is a part of your management plane. So management plane will take care by the vManage of your SD-WAN fabric. So in your SD-WAN fabric, we have a vManage as a controller. This is the one of the controller which will provide you the single pane of glass for management purpose, configuration purpose, and for your troubleshooting purpose. Your entire devices, like if you have 1,000 devices, 10,000 devices, it can easily able to manage. That kind of flexibility benefit you will get. Now, think about here. Let's suppose you have some routers here as well at the MPLS level, maybe. Okay. I'm just writing few of them only, not all of them, but you have a routers here, right? And what MPLS will tell you, they will tell you, you can run the routing protocols here, you can run the routing protocols here, right? You can run. Now guys, just think about the situation. Let's suppose you have run one of the protocol which is OSPF in your environment. Now when you will run the OSPF, so your each routers, this R4 he will advertise subnets, right? Means this R3 router, he will get the subnets or advertisement from all these routers, right? Let's say you have 100 routers or 1,000 router in your topology, which means your one router, he will receive the routing updates or prefix from 999 routers, right? 999 routers, they are going to advertise their prefixes. And now this router, what he needs to do, he needs to do the entire calculation, right? In this router, he's having route processor. Now this route processor, it will basically run the OSPF process, right? He will run the SPF algorithm. He will calculate the best path. All these things it needs to do, right? It will manage the LSDB database. It will responsible for manage your network discovery table, right? Or your neighbor discovery table. All these things this router needs to do for all the router, which whatever you are having in your topology. Same thing this router also needs to do, same thing this device also needs to do, same thing this device also needs to do. Which means if you have a 1,000 router, which means one router he needs to maintain 9,999 your OSPF neighbor tables, your LS OSPF database. It needs to run lots of calculation. When it will run these calculation and all, guys, which means it will take your CPU utilization, right? And it will also take your memory utilization. These things will require, right? Now in your SD-WAN, what they have done, they just said to these routers, they have removed the control plane from these routers. What they will just say, we have one controller, the name is vSmart. All these routers, they can send the routing details or whatever prefix they are having to this vSmart. They don't need to send to each other. They can just send this particular routing details to this vSmart. Now this vSmart, what he will do, he will run the calculation. He will maintain your data routing database. So which means he will maintain your RIP database, routing information base. And from this routing information base, he will run the algorithm and he will basically just send the routing table, or I can say it will update regarding the FIP table to these devices. Means R1, he don't need to do any kind of calculation. He will get, this is the FIP table. So your vSmart device will do the calculation, everything. Which means now we have removed the control plane functionality from all your 1,000 devices. We have just put here one controller, and this controller will do all type of calculation, and he is just directly providing the FIP table. So guys, in your SD-WAN, what they have done, they have removed the management plane and the control plane functionality from your routers, these VANS routers. These VANS routers, they just have the data plane only. And guys, if you know, data plane will responsible for the forwarding of the user's traffic, your server's traffic, right? So these routers now, they will just do the data plane activities. Your management plane and control plane activities is taken care by the SD-WAN controllers, which is your vManage, vSmart, right? So that's how your basically SD-WAN come in a picture. And how SD-WAN is basically managing these things. They are managing with the help of controllers, and they are using the software defined approach here. Which means previously, if you will see in this example, guys, in this example, if you will see, all this thing of your entire fabric, like all your 1,000 devices, is you are doing with the one device which is known as vManager. All your vManage or your management plane activities then you are managing from the vManage. All your LSDB database, your neighbor table, your SPF algorithm calculation, your authentication, your hello messages, ARP table, everything, your RIP table, all these route processors functionality is now managed by one of the controller is known as vSmart controller of your SD-WAN. You have removed, when you will remove this functionality from a device, because you know, on this device, basically, they are having some shared resources, right? Maybe your R1, he is just having, let's suppose, he is having around 16 GB of RAM, and it is having around, let's suppose, 120 GB of SSD, and let's suppose it is having around 16 CPU. It is having around 16 CPUs, which means let's take a very minimal number now. Let's suppose for your management plane functionality, let's suppose it's needed around 2 GB of RAM, and let's suppose it also needed around 2 CPUs. Your control plane, let's suppose it's needed around 6 GB of RAM for running your algorithms and all the your OSP process, your EIGRP process, your BGP process, right? And let's suppose it's also needs some memory, some basically RAM or some CPUs. Let's suppose it needs around, I will mention it, 8 CPUs. Now for your data plane, how many resources is left? So for your data plane, only you have a 8 GB of RAM, and you just have only 6 CPUs, right? Who will do the data plane activities, guys? Who will basically forward the traffic of these devices, these servers or your systems? But guys, in SD-WAN, because they have removed this management functionalities, they have removed the control plane functionality, which means now whatever resources you are having into these devices, you can utilize them on your data forwarding, guys, as a data traffic. So that kind of benefit basically you will basically get with the help of SD-WAN, guys. So now if I'll tell you the SD-WAN architecture, in your SD-WAN, we have three things. First thing is known as your vManager, which will take care of the management plane of your routers. This vManager, you can basically manage, it will provide you the graphical user interface for the interaction. So your network admin, they can access vManager with the help of graphical user interface. Either you can also allow to access with the CLI. Both options you will get. Apart from this guy, you can, if you are very good with the programming, which means it can also communicate with the APIs. It will able to communicate with the API calls as well. Means if you are an automation guy, which means you can also automate lots of tasks. This device, it will also provide you the health of your entire fabric. Now you don't need to basically maintain the configuration of each and every device on at your backup servers. No, you can basically just maintain the backup file of your vManager because it has all the configuration. So such kind of benefit you will get. Now you don't need to upgrade the devices one by one. You can just upgrade the devices in one go from this vManager. So that kind of flexibility you will get. That kind of scalability you will get with the help of this vManager controller, guys. There is a one more controller we are having, which is vWAN. That controller will take care of the orchestration of your SD-WAN fabric. Let me just tell you the simple term for orchestration. It will take care of the authentication. It will take care of the authentication of your VANED routers, because your VANED router needs to connect with vManager, right? They need to connect with your vSmart controllers. They need some kind of connection. Now, how will make sure the router who is trying to connect with your controllers, it is a correct or not? These part is taken care by the WAN controllers, guys. And after that, your routing related things is taken care by the vSmart controllers. It will take care the entire control plane of your traditional WAN is routers basically. And you can, we have a, these are your WAN is routers basically in your cloud, in your data center, in your campus network, in your branch network. This is also known as V edge routers. They are just having the data plane functionality. They are the controllers who will basically do the traffic forwarding, guys. Okay, so these are the, we can say, some overview of your SD-WAN, how SD-WAN came in a picture, guys. If you will see into this picture, the same thing, you have the same type of things, guys. So I will not go too much today, guys, because it's just a demo class. So now I'm just stopping here. Okay, guys, so you have the mute permissions. Now let me just tell you one more time, guys. So this particular batch I'm starting from 10th of September. It's a weekends classes, and your classes will happen Saturday, Sunday, 6 p.m. to 8 p.m. IST. Now if you have any question, you can unmute yourself and you can ask.